All right, thanks a lot for coming. This is going to be a talk called Creating XR Stories. My name is Dan Miller. I work for Unity Technologies as an XR evangelist, which means I travel around a fair amount, give a lot of presentations and talks, things like that, and mostly focus on augmented and virtual reality. This means I also build a lot of sample applications, and I've been fortunate enough to go to certain kind of film experiences and film festivals like Sundance as well as Tribeca. And I've gotten the opportunity to try out a lot of what I would consider XR stories. So these are kind of stories taking place in virtual or augmented reality. In today's talk, I'm going to cover a variety of different topics. I'm going to start off just kind of defining what I call XR stories so we can get a little better grounding for the presentation. Next, I'm going to go into some specific tools and things that are built into Unity so that you can start taking advantage of these, things that I use and a lot of my prototypes and things like that, as well as things that I'm starting to see used in some of these storytelling experiences. Next, I'll dive into spatialized audio. It's going to be more of a bit of a high-level overview of what's supported in Unity, how to start taking advantage of some of the different spatializers and things built in, as well as just some of the features included in those. Next, I'll talk a little bit about 360 video, what's supported in Unity, how you can utilize it, and how you can kind of take it to the next level. And last but not least, I'll talk about a little bit of samples for things that I've seen for kind of triggering events in the application, as well as just pushing the visual fidelity and quality in XR. So first, what are XR stories? So if you recognize this image, you'll know that it's from a small kind of VR short by Baobab Studios. And what it is it basically puts the user as the kind of camera in the scene. And so what I'm defining here as XR stories is really any story-driven experience in virtual or augmented reality. And I've seen a wide kind of range between things that are completely passive. So you as a user is just taking in the viewing experience. Maybe things are happening all around you. Maybe things are only happening right in front of you, but you don't really interact with it. And then there's also some where they're starting to really mix in kind of player-driven experiences where you're making some decisions, you're interacting with the story as it takes place, or you're even moving the story along. And I think from kind of an industry standpoint, a lot of the experiences I tried a few years ago were a lot more on the passive side, and now we're seeing some of this more interactivity and things like that built into the experience to really give the user or the viewer more control. And so there's really, again, kind of a wide variety. Here's just a couple samples here. On the top, we actually have an AR kit experience, or it's using augmented reality to kind of capture the world. They've placed a digital character as it kind of walks around the environment. It's kind of a little rainy environment here, so the character really blends in with it. And they're using that camera feed as the kind of camera in the experience itself. We also have over there on the left is an experience called Queer Skins. And what it does is it uses a combination of depth capture for the actual characters or for the actors and actresses, and then uses some photogrammetry and some real 3D world environment to actually put you in the backseat of a car as you kind of move through this experience. And then we also have some 360 video here, as well as just kind of a character there. And there's a lot of different ways that I'm seeing people kind of capture and bring characters into the world. And obviously, character capturing and kind of displaying is some of the more challenging things that we're seeing right now. So, presenting people in this more silhouetted view or maybe just capturing the face is something I'm seeing a lot of. And so now I just want to talk about some of the tools built into Unity that will allow you to start kind of utilizing and things that I've been developing and things that I'm seeing people kind of develop these stories with. So here at Siggraph, we're showing a variety of different kind of film-centric things that Unity is doing. And a lot of these were built on this tool, Timeline. And if you're not familiar with Timeline, it's basically a way to sequence things together within Unity. And one of the interesting things to me is that it really changes the way you interact and iterate within Unity itself. In the past, before Timeline, or even still with certain systems, you often set up your system, decide what sort of timing you want, hit the play button, go into the editor, and then wait for that experience or wait for that trigger to happen. And with timeline, what you can do is you can actually scrub through in edit mode your certain timings and things like that. You can see here, this is just a clip where I'm cutting between two animations, and then I can easily push those together, which create a blend between the two animations. And again, this is all in edit mode. I'm kind of moving time forward within the editor on the timeline itself, and I'm not having to set up these sequences, have it blend from the idle to the walk animation, and then see that at a certain point. I can just use my mouse, as you can see there, to kind of just scrub this little timeline here. And it works really well for what we're visualizing right here, which is things like blending animation together. So you have two animations that you want to transition from one to the next. And the cool thing is that because it's all visual based, you can actually kind of control how that blend works. If I just jam them together a little bit, he'd go from idle right into the run. But as you see, I've kind of elongated it, and so he takes a little bit of time as he goes into that full animation. The other thing, as far as kind of film and setting up some certain timings, is you can easily convert based on time, so specific seconds or milliseconds, as well as frames. You want something to happen 20 frames after another. You can really get down to the kind of nitty-gritty within timeline. And the other and last thing is that it's super extendable, and we're seeing people start to use this in kind of unique ways that are specific to their story. Maybe you have a timeline that kind of gets to a certain point and then idles there until the user performs an action or something like that. And you can really kind of customize this in depending on the story or the experience you're trying to tell. All right, so now I want to talk a little bit about kind of XR toolkits. And I'm seeing these used a lot, especially in the kind of community that is developing a lot of these XR stories. So a lot of people might not necessarily come from the most technical background, and really they have this story or experience that they want to tell, and they want to just start hitting the ground running. They want to start building things up. They want to start creating right away and not necessarily worry about the kind of heavy lifting or really trying to reinvent the wheel. So what I want to do now is just kind of go over some of the toolkits that I've utilized and some of the ones I've seen utilized, and just give a brief example of how they work. So on the handheld AR side, so this is AR Core and AR Kit, we have a couple experiences here. On the top there, that's just a GIF of Hello AR, which is included in the AR Core experience. And what this does is just easily find horizontal and vertical planes, and then allow you to basically spawn a prefab on them. So if you had created a kind of mini diorama or a story within Unity itself, and you wanted to bring it into AR, you happen to have an Android device that's compatible, you can easily download this AR Core Unity SDK and just place it in the world. So again, kind of very simple things there. On the bottom right here with the blue outline and the kind of yellow square there, that is from the AR Kit SDK. And unlike the AR Core SDK, which is actually maintained and developed by Google, the AR Kit one is actually developed internally at Unity. And what that means is that there's a lot of samples and things like that. This one's specifically something we call a focus square, which is basically just kind of focusing the user in the kind of center of their device as they're looking around for kind of placing objects in the world. And last but not least, the other one down there with the red cube is our AR Foundation sample. This is actually something that I'm contributing to, and what it is an abstracted layer between ARKit and AR Core that it kind of glues them together and gives you this core functionality. So if you're building an AR story experience for handheld AR, I would definitely recommend checking out AR Foundation, as it allows you to build to both ARKit and AR Core using the same code base. On the head-mounted AR side, so looking at things like the HoloLens and the Magic Leap, the HoloLens actually has a toolkit called the Windows Mixed Reality Toolkit. And similar to some other things we'll see is that there's a lot of built-up samples and a lot of things that you can start utilizing right away for just very basic things. You know, you want your user to interact with an object. You want your user to be able to use both hands to maybe scale things or manipulate objects. And what Windows MRTK does is it actually allows you to build within this mixed reality environment. And so this means that you could build it out for the HoloLens or the Windows Mixed Reality Virtual Reality kind of headset line as well. And you can see that there. It's kind of the same interaction happening with two gestures as well as with two controllers. On the Magic Leap side, this is a kind of small demo that I've built here, and it's actually showing off some of the hand tracking APIs. And what they do is they provide the Magic Leap for Unity SDK, and it has a lot of these sample scenes that are basic kind of functionality that you might want to use within your experience already built up. So you can kind of just take these scenes, maybe duplicate them, and really start building on top of them. And that's how I end up building a lot of my kind of demos and samples. For the mobile VR, Oculus provides something called the Oculus Utilities for Unity. And this actually covers both mobile and high-end. In the bottom right here, you can see with the little Oculus Go controller that I'm moving around, this is one of the sample scenes that's included there. And what it does is it actually goes through, and that's a small UI. It's a little bit hard to read on the 2D image here, but in the headset it's a little clearer. And what it does is it showcases basically all of the kind of values that you're manipulating on the controller itself. So if you want to kind of understand how those get called back through code, this is a nice little sample scene for that. The other two images listed here are from something called Google Daydream Elements. And what this is basically a collection of UI and UX experiences built within Unity for the Daydream platform. And if you're not familiar, the Google Daydream platform is kind of their mobile virtual reality platform. And at the top there, we have a way to just kind of grab and manipulate objects. And the bottom there, we actually have a kind of shader effect that's tunneling your vision as you kind of move throughout the space. So as you guys might be familiar with virtual reality, you always got to be a little bit conscious of how you're moving the player for things like motion sickness. And this is a good way to ground the player as well as kind of move them from one place to another. It's kind of this tunneling effect so that they feel a little more grounded and less nauseous. And I definitely recommend checking these out. Daydream Elements has a lot more stuff than I mentioned here, as well as the Oculus Utilities as well for things like grabbing. For the high-end VR toolkits, again, the Oculus Unity Utilities has a little bit of physics as well as kind of moving and manipulating around with the controller itself. Something I've built on top of as well is at the top there, which is the Steam VR plugin. So Valve uses Unity for a variety of different projects, and one of them was the lab, if you're familiar with that. Most of the experiences in that were built with Unity. And what they did is they actually went and kind of packaged up some of their scripting and tooling specifically for VR in Unity, and then released this for free on the asset store. So you can see there, it's kind of a little playground environment. They actually have the bow from Longbow, if you're familiar with that, which kind of showcases some grabbing as well as physics elements. And then on the bottom here, we have a really popular toolkit called VRTK, or Virtual Reality Toolkit. And what this does is this has upwards of something like 60 plus scenes of a lot of different kind of very basic samples of things like physics, you know, opening some levers, pushing buttons, and things like that. It also has a lot of stuff for moving around, whether you want to do some teleportation or some dash effects and stuff. So I definitely recommend checking this out. All of these are completely free and available, and it's a great place to kind of get started and start building right away. All right, and last but not least, I did want to mention the asset store. If you guys aren't familiar, Unity has kind of a marketplace built into it that allows you to go and kind of buy and sell assets. And there's a lot of ones now specifically being built up for VR. So we have that tunneling effect that's kind of similar to the Daydream Elements one, but it works on all platforms. And then there's a little pack there as well. And one I wanted to point out there in the bottom is something called Final IK. And I've seen this or a kind of variance of this used in a lot of different experiences. And what it does is it gives you the ability to basically rig up a character that allows you to get this kind of body presence. So if you're not familiar, IK in this case stands for inverse kinematics. And what this means is that you can see on the top the character is kind of moving around. And on the bottom, this is actually the first person view. So this person is kind of moving the controllers and is controlling these hands and body. And as they dip down a little bit, you'll see their legs move. And really, I'm seeing this used in ways where people are kind of viewing themselves in the mirror, as well as just kind of body presence. It can make you, you look down, you see someone else's body. Maybe that's part of the experience or the story you want to tell. And so, yeah, Final IK specifically comes with some scenes and things like that to hook it up to VR, where you're attaching the camera as the user's head, and then the controllers, and then it'll do some basically mathematics and calculations to kind of determine where the elbows are at, how things are moving and bending there. All right, so now I just want to talk about spatialized audio. So Unity basically supports spatialized audio, and I'm going to walk through a little bit of how to kind of set it up, and then some of the spatializers that we have built in. Now, before I mention that, I do want to say that certain spatializers or certain of these kind of plugins or integrations are platform specific. So you do have to keep that in mind. Things like the Microsoft one only work on Windows 10 or only work on some of their headsets and things like that. So just keep that in mind as you're kind of exploring some of these. And as I'm sure you guys are aware, with any sort of XR story, whether it be virtual or augmented reality, audio is always a really good way to kind of focus the user or give some intention to the player. The challenge with XR stories, especially with virtual reality and augmented reality now with a lot of the headsets and the handheld devices, is that really the user can go and do whatever they want. If someone wants to look over here and wants to just look off in the abyss and your story is going on behind them, you can't really control them, doing that. They can go and look where they want. They can walk where they want a lot of the times. They can move around. And so using audio as a kind of cue or as a way to draw the user towards the experience or towards what is happening that you want them to see is a really good way to do that. And us as humans have really understood and kind of evolved with using our two ears to understand where sound is coming from. If someone's in the back and happens to come in and slam the door, almost everyone's going to realize that that's coming from behind them. And so you can use these spatialized audio cues and use these spatializers to really build up environments that sound and emulate some realistic ways, as well as just get the user to explore. You might find that a lot of your users are only looking straight, they never turn around, and maybe they've really never used VR before. But if you start to have noises playing around behind them, then that might get some people to start looking around, might get people a little more engaged. All right, so configuring spatialized audio in Unity. So this is an audio source, which is just kind of the built-in component here for audio. And you'll see that in this red here, there's actually a slider here called Spatialized Blend. And what that does is it basically sets the value for how the audio source specifically is going to be recognized within 3D space, so where it's at positionally. Now, one thing to keep in mind is that if you don't assign a spatializer within the audio settings itself, this 3D setting is only it's gonna work basically where it's at positionally, but you're only gonna be hearing it out of one ear. So what that means is if there's an audio source over here playing something like this, it'll be as if my other ear is kind of completely muted and I'm only hearing it from one side. In order to make it a little more spatialized and a little more realistic, as if I have two ears, this is where the spatializer plugins come in. So if you've assigned a spatializer plugin, at the very bottom of your audio source, there's going to be a spatialized checkbox. And what this is going to do is, depending on the plugin, there'll be some slightly different kind of calculations for it, but it allows it to play the audio louder in one ear and softer in another. And again, it's going to use this kind of positional value depending on where it's at within the scene to allow that to happen. And really what it does is just make it feel a lot more real. I can't really think of any use case in the real world, unless maybe we're lying down in bed and one of our ears is completely covered, that we're really only hearing sound from one ear. And so this spatializer, again, you can put the spatialized blend, but really you're going to want to use one of these to make it a lot more realistic. And so again, here in the Spatialized plugin, as I was mentioned, it kind of puts the sound in both ears. And this is just the audio manager. So if you go in Unity, project settings, audio, you're going to see these settings here. And this one highlighted down there is the actual spatializer that you want to put in yourself. So there's going to be a drop down depending, again, on what platform you're targeting or what platform you're on currently. You might see some different options here. Right now I'm running this, this PowerPoint or this presentation off of a Mac. So if I go over, and I go into my audio settings, I'm not going to see the Microsoft one. And that's because I'm kind of targeting the Mac environment, and it's really only available on Windows 10. All right, so speaking of Microsoft, so the Microsoft plugin is called the Microsoft HRFT Spatializer, which is head-related transform functions. And basically, as we got these virtual reality headsets and things like that, we now have a user's tracked head, and we now need to kind of make these calculations based on where the user's head is kind of positioned, as well as the rotation of it. And so what this plugin does is it basically has a variety of different settings that you can apply to the audio sources itself, and it has some drop downs for things like room size. This room right here might be kind of a medium-sized room, and what you can do is you can kind of position this within your environment itself. So if you're using the Microsoft Spatializer, you attach some scripts to your audio source, you set up your actually playback clip, what you're going to play in the audio, and then you define a kind of room size, and that's going to give you a little bit of kind of resonance and things like that, so that if I'm talking in a room of this size, or if I'm talking out in the hallway or out in the main hall and something like that, you're going to get a little bit different of an audio kind of sound. And what you can do is kind of specify that. There's also a really good document that I kind of linked up here, which is actually from Microsoft on their own documentation themselves, which goes a little bit into spatialized sound design, thinking about it, how you're capturing it, how you're kind of bringing it into Unity and stuff like that. So I definitely recommend checking this out. And again, there's a lot of sample scenes and things included, specifically in that Windows Mixed Reality Toolkit that I mentioned earlier. All right, so for the Oculus Spatializer, again, it kind of has dynamic room modeling, which allows you to get some of those reflections. This is kind of one of the sample scenes included in the Oculus Utilities. And you can see that little kind of box around the capsule, and that's actually the kind of modeling of the room itself. So depending on where your experience or environment takes place, you can kind of modify this to kind of be the size of the environment that you're in. And it also has the ability to support kind of ambiosonics. So if you're creating something like a 360 video and you want just the audio to play all around the user, but in a more spatialized way, how they're looking, you can do that as well with their plugin here. All right, so the last one is resonance audio. So this was originally, and it still is, kind of developed and maintained by Google. It originally was released as part of the Daydream Elements, and a lot of people thought that it was kind of specific or only worked on the Android platform. They've actually built it out a lot more, and there was never really that restriction, and so they've kind of rebranded it as what they call resonance audio. And again, this is a way to kind of spatialize your sound within your environment, but this one specifically has a couple more unique features included in it. So it has things like geometry-based reverb, where you can actually go in, specify the environment that your sound is going to be playing in, and then kind of go and start to bake in these different sound sources. And they actually have these things with kind of audio probes, where you can specify, if the user is moving from here to over here, maybe I'm moving into a larger room or something like that, and you can really specify how the sound is reacting in that environment. The other really cool thing to me is that they actually have surface materials. The environment we're in right now maybe has a little bit of kind of noise canceling at the top there. We're at these walls right now, But if I was in something like a completely foam room, or I was in a house with a lot of big curtains, or as I was in a really big, empty kind of concrete room, you can actually go in and specify material values on your geometry within the scene, and then bake that into the whole experience. And again, this is just kind of trying to take the audio experience and bring it to the next level and emulate what your virtual reality or augmented reality experience might be like. It also has, in that effect, it also has things like occlusion. If I was, I mean, you guys are hearing myself out of these speakers here, but if I was kind of talking to you normally and started kind of hiding behind this bench or something like that, you're going to hear me a little bit differently. The sound is going to be bouncing off this and not getting directly kind of out to you guys. And again, these are all kind of freely available. It's more of a platform-specific thing. Resonance Audio is one of the ones that supports more of the wider platforms. So yeah, just kind of keep that in mind. All right, so now I want to talk a little bit about 360 video. So when I started kind of, when I first joined Unity and started going to a lot of these film festivals and things like that, seeing a lot of these XR stories, a large majority of them were 360 video. And while I still think there's a lot of really meaningful experiences that you can have with 360 video, I think what we're seeing now is kind of the evolution of just the basic storytelling experience outside of kind of a flat 360 video here. And so if you're not familiar, this is kind of a little bit of how just the 360 videos work. They basically are rectangular and then get wrapped around a sphere, and you kind of place your user inside them. So in Unity, we support native 360 video, or really just native video playing. We can do 4K, 8K, or higher. And on all the platforms, there's kind of hardware acceleration to be able to play those videos as kind of as well as possible. And with our 360 video support, we have things like this interactive 360 sample project that allows you to go in, view different videos, and then it's configured with this kind of abstract, what we call a tracked pose driver, so that it works for a variety of different VR headsets and VR kind of systems here. So if you want to view this on something like the Oculus Go or something like the HTC Vive, you could go ahead and do that because it's already kind of configured with that. So I definitely recommend checking this out. There's also some 360 videos that are both stereoscopic and monoscopic included, and you can kind of see the difference between those as well. I did want to show this briefly here. And what this is in Unity 2018.1, we introduced the ability to actually capture 360 videos within the Unity editor itself. So this is a video captured within Unity, rendering here for both eyes. So we have the left and right eye, so that it's actually a stereo video. And the cool thing with this is that in Unity, you might have a really high fidelity scene, you might have a lot of stuff going on, and it could just be too expensive for VR. And if it's too expensive, you're going to get bad performance, you might not be able to render it. But if you kind of capture it out to a stereo video, and then maybe use this as a backdrop and start to kind of layer in 3D elements, then you can kind of get this fidelity, but still have it be much more performant than if you had all the geometry, all the particle effects, and things like that in your experience. And so with that, I just wanted to briefly show this little GIF here. And this is what I'm starting to see where people are really taking 360 experiences or 360 captures kind of to the next level. So in Unity, or I mean rather outside of Unity, people are shooting and recording a lot of 360 video, and we're seeing them being played back, and there's definitely some meaningful experiences. It's fun to kind of look around. But what I'm starting to see at a lot of these film festivals and how people are taking them to the next level is they're using this default 360 video and then layering in these 3D elements. And the cool thing is that depending on if you're using something like a mobile VR headset where the user is only rotationally tracked and not positionally tracked, you can actually use where the camera is at as kind of a perspective trick to put elements in the environment. And so down here, this is what you're seeing rendered from kind of the user's camera. And it looks like that guy is kind of standing there with some boxes in the camera or in the kind of video itself. But at top, I'm just kind of showing you moving the perspective around and how really it's a 360 video that's kind of rendered here at the outer bounds, and then just these 3D elements kind of layered in. And again, this really kind of allows the user or the viewer a little bit more depth cues, really, ups the immersion and things like that when you're starting to mix 360 video and experiences with some of these 3D models and things like that. And again, with Unity, it's really easy to start layering these things in, start to add some animations, particle effects, stuff like that. All right, so I talked a little bit at the beginning about kind of triggering events and how those work. And what I've seen a lot with more passive experiences where you as the viewer is just kind of viewing things. And what I think is exciting is a lot more of these more kind of player-driven experiences. And maybe that means that you're waiting for a specific event to happen. Maybe that means that just the player is allowed to kind of move around. And so I just want to touch on a couple of them that I've seen here and how you might do it in Unity. So for triggering events, a lot of the times what I'm seeing is things like gaze-based. And what that means is that basically you're waiting for the user to specifically kind of look at a specific object or a specific part of the scene. So with these 360 videos, if you just have a 3D environment where things are laying out, again, the user can really look or do whatever they want. They can be spinning around the whole time. They can be kind of looking over here. And using things like audio or other certain cues, you can hopefully lead and guide the player to where you want to look. And what I think is really cool is when a bunch of things are happening, maybe things are happening behind me, but I want to explore a little bit. And then when I finally start looking back at the action, that's when things kind of start to move forward, or that's when things start to progress. And again, it's kind of giving the user a little bit more control over the experience. And so in Unity, you could easily do something like a raycast or a sphere cast, which is kind of a little bit larger, out of the user's camera or out of the kind of, out of the user's camera or their eyes to be able to tell exactly where they're looking. And then when they get over to an experience or when they look at what you want, you can kind of move things based on that. The other big one that I'm seeing is what I'm calling action-based. So a lot of the times there's certain experiences and they go into this certain loop. And maybe audio is playing, or maybe certain actors have kind of said what they wanted to say, and then they're really just waiting for you to progress it. And so for this, I'm seeing a lot of things where maybe you have tracked VR controllers and it's waiting for the user to specifically do an action. And that could be as simple as grabbing an object. That could be grabbing an object and placing it somewhere. And really what you're doing is you're allowing the user to interact within the experience. You're allowing the user to wait until they're ready to kind of move on and start progressing. And so in Unity, you could easily do something with event-based systems where you're kind of calling to other scripts, so you're listening to certain events, as well as things like object placement. So I've seen a lot of these things where you really want to guide the user to put something in a specific spot. So maybe right when they grab it, or right when they've kind of attached it to their controller, then you place kind of an outline or like a ghost version of that object so that they know where to place it, or you're kind of guiding the user along. One of the things I've seen a lot with these XR experiences is that it's really easy to kind of play the whole experience themselves. And sometimes this is part of it where a user might have missed something or there's a lot going on, so you need to play through it multiple times. But it's really easy to kind of have it all happen, and maybe the user even misses that key moment or that important part of your story. And so to me, it's really a good idea to kind of start thinking about how does the user complete the experience? How does the user get involved so that they don't miss those big opportunities or the big kind of moments within the story itself? And lastly, I just want to kind of briefly mention testing within the editor. So over here, this is basically that kind of VR experience that I showed earlier. And what you can do is you can easily set up a script. So this is kind of a 360 video. And now I'm actually using my mouse here to move around and look throughout the environment. So if you're also familiar with developing for VR in Unity, especially on the high-end systems, it's really easy to have your VR headset hooked up, just hit the play button, and it'll start rendering out to the headset. But if maybe you're on the go or you're developing something like a mobile VR application, it's really nice and convenient to hit the play button and then set up this simple kind of look script where as I rotate and move my mouse, it's just the same as if I'm looking around in something like an Oculus Go or a mobile VR headset there. And so this can be really good for, again, kind of testing those experiences. And you can see here with the perspective that it does kind of look like the character is standing over there and the boxes are like that. And you can see, I can even kind of go and grab them like this. And so you can start to see where they're placed. So they're really just kind of here in 3D space. But the way that the camera is actually looking at them, that's how we're really getting that kind of perspective and things like that. All right, so now I want to talk a little bit about visual quality in XR. So how many of you guys in the audience are familiar with Unity's scriptable render pipeline, or SRP? A couple people, that's cool. So what we've done recently in the 2018 version of Unity is we're trying to open up the black box that is Unity rendering. In the past, a lot of things are just compiled into the engine. You're using certain shaders and things like that. And we've also supported a lot of kind of legacy platforms. If you want to create a Unity application and run it on a refrigerator, that's possible. If you want to create a really high fidelity XR experience for VR or AR, the ability to render to a refrigerator is actually kind of hindering you a little bit. And it's been kind of some technical debt that we've been moving along with. And so with the SRP, or the scriptable render pipeline, what we're trying to do is we're trying to leave some of that behind in what we're calling the legacy renderer and build different and more modern rendering pipelines that allow you to get more performance and that are really focused on these modern platforms. So things like augmented and virtual reality. And what we're doing for that is the first thing we're shipping, or something that's really already shipped, is what we call the LWRP, or the lightweight render pipeline. And what this is this is basically a render pipeline in Unity that is more focused on these modern platforms. And that means that it's super lightweight, it's really flexible, and it's even more performant than the legacy renderer. So I recently did some benchmark tests here with the Oculus Go. And we have some sample scenes from the graphics teams at Unity. And in the legacy pipeline, so the old kind of renderer, which you would be getting in versions Unity 2017 and before, and it's still possible to get it in the 2018 version, is basically I was able to get 44 frames a second on the Oculus Go. And if you're familiar, the Oculus Go has a minimum, or really the kind of minimum threshold is 60 frames a second, and that's specific to mobile VR. And the Oculus Utilities allow you to actually push this limit up to 72, which is the maximum that the Oculus Go can go. But with the lightweight render pipeline, I was able to easily achieve 60 frames a second, and then using the Oculus Utilities, kind of push it to that next level. So again, the lightweight render pipeline, this is what we originally built and targeted specifically for all these kind of modern platforms, from everywhere from mobile, PC, console, things like that. And then we've also been building what we call the HD render pipeline. And so this stands for high definition. And while initially we weren't really sure on the exact specifics or the amount of work it would take to get the HD render pipeline available and rendering for VR, I'm excited to say that we have an internal prototype of this actually working. We're hoping to showcase a little bit of things here at Siggraph, but don't quote me on that or go to the Unity booth and ask about it. But what we're doing is we've basically done some internal work on it, and we're allowing users starting next year, when a lot of this work is going to hit trunk, the newer versions of Unity, to be able to render and develop with the HD render pipeline in VR. And if you're not familiar with the HD render pipeline, it is basically what we're doing is we're taking the lightweight render pipeline, which is flexible for a lot of different systems. We're really pushing it to the high end and putting in a lot of these modern graphics techniques. So everything from things like iridescence, which you're seeing there on the bubbles, to subsurface scattering, which you might see in human skin, as well as things like plants and foliage, and really just including this in the render pipeline. And so we're also, if you're familiar, Unity recently announced its automotive initiative. And what this is this is a way, or what we're doing here is we're basically building up some tooling for the automotive industry. And included with that is a set of materials specifically built on the HD render pipeline for things like the clear coat shader or paint that you might see on cars, leathers, and certain fabrics that you might see in cars. And again, those are all built in the HD render pipeline because we're really trying to push the visual fidelity. And starting next year, you'll be able to start to use those in virtual reality as well. I can say we're also doing a lot of work to try to get the lightweight render pipeline available for augmented reality. That's something that we're looking at for the AR Foundation in order to start taking advantage of some of the new graphics features that these render pipelines allow you to access. So things like our shader graph, which is a new visual node editor for creating shaders. Right now, that's restricted to lightweight render pipeline and HD render pipeline. And so bringing VR support to the HD render pipeline and then bringing AR support to lightweight is really going to open up a lot of those opportunities. All right, so that's pretty much it for my talk. If you guys have any questions or anything like that, I think we have some time available for that. Yep.
So with the new render pipeline, I noticed also that you've done some collaboration with Otoy with their Octane renderer. Does that have any application in AR or XR?
So right now, the Otoy renderer is kind of its own separate thing. Now, it's not necessarily tied into our render pipelines right now. It's kind of an additional add-on that allows you to render that out. I know that they're exploring, and kind of together we're exploring ways to bring that visual fidelity into VR, but I haven't heard any specifics on that. Any other questions? Yep.
So is there a way to render things layer by layer in Unity? Let's say you have all this big crowd in the back and you want to render all that crowd and then just animate or change your main characters, and how do you do that? Is there a way to do that, or every time you click the play button, you're just re-rendering everything?
Yeah, so the question was kind of about basically rendering things in certain layers. So what you can do is you can actually specify, there is a layering system in Unity that allows you to specify just certain groups of objects. And then on a per camera basis, you can specify a layer mask that you're telling exactly what you want that camera to render.
Oh, but what if I want to render something just once, and then I want to use that for all the future renders? But then with a camera, you're just rendering things separately, right?
Yeah. So I guess the solution for that might be something called a render texture, which allows you to basically take a camera, render it out to a specific texture, and then use that in different ways or different places. Okay. Does that make sense, or is that not answering your question?
I'm still a little confused, but maybe I'm not sure what the rendering texture you're talking about refers to, but then maybe I'll look that up. And then,
okay.
Yeah. Thanks.
Yep. All right. Oh, go ahead.
Hey, real quick, I had a question about those sample projects you had earlier on.
Mm-hmm.
I'm creating a class in the fall that's going to be using Samsung Galaxy S8s for AR and mobile VR. We have Gear VRs as well. I'm in the IT side, and I'm just trying to show them like all the features of Unity for AR and VR and kind of let them on their way. to go develop their own projects. Can you recommend any of those sample projects for use in the class?
Yeah, so I mean, the kind of utilities and things like that. Let me just jump back here. Yeah, so you know, I will say the Daydream Elements for Google, while it is specifically kind of authored and was originally created for their mobile platform, there's really nothing restricting it to Daydream. So if you wanted to use that on Gear VR, I think it's certainly possible to download that and then build out an application for the Gear VR. And also Oculus Utilities. Again, it's not something that's really going to necessarily wow someone, but it is a nice collection of assets. For AR, for handheld AR, the AR Core Hello AR is, again, kind of very straightforward example. With the AR Foundation samples that you see in the bottom right, we are trying to build out a little bit of a more robust sample pack. So potentially there could be some cool use cases for that. But if not, you can, we do have a couple what we call kind of highlight reels and things like that of Unity for handheld AR. So you could potentially find those on the web, or you can reach out to me and I can kind of link you some of those. You know, a lot of people ask, you know, what are some big games made in Unity that's utilizing AR? And so if you guys are familiar with Pokemon Go, that's made in Unity. They've started to use ARKit on the iOS platform to actually kind of enhance the Pokemon finding experience, for example. So you actually search around, find a plane, some grass comes up, and then you shake one of the grasses and the Pokemon comes out. And then using ARKit, if you actually go too close to the Pokemon, then it'll kind of run away. So there's some kind of interesting use cases that we're seeing right there. And again, that's all kind of built in Unity. All right, so I'll be around outside if you guys have any more questions, but thanks for coming.